They draw the shear force and bending moment diagram for the following beam. Here you can see the beam length is equal 8 meter. At the 6 meter distance from AN, the point load 100 kilonewton force is applied. Okay. Let's see how to draw the shear force and bending moment diagram for this kind of beam. As the first step, we have to find the support reactions. That is the first step in this kind of, when solving this kind of problem. To find the support reaction, first we have to draw the free body diagram for the entire beam. Free body diagram for the entire beam. Okay, let me draw the free body diagram for the entire beam. This is the beam. The point load acting is equal 100 kilonewton at 6 meters from AN. This length is equal to 2 meters. Here R A Y, the pin support reactions, R A X R B. Here the roll support, that is acting, the reaction acting upward direction. Here R A X is equal to 0 because no any lateral forces or horizontal forces acting on this beam. So all the forces acting in vertical direction, so that R A X should be equal to 0. Okay. So then then you can find the R A Y. R A Y is equal, the length of the beam is equal to 8. The 2 divided by 8 into 100. Then the RB is equal 6 divided by 8 into 100. By taking the ratio of this distance, we can easily calculate this one. Let's take this point as C. So then RAY is equal 25 kilonewton. RAB is equal 75 kilonewton. Okay. So then the next step, divide the beam into a segment so that the loading within each segment is continuous. If you take A to B region, the loading is continuous. There's no loading acting on this A to C region, but at the C point that is discontinuous due to the acting of point load 100 kilonewton. So that we have to divide this entire beam into two segments, A to C and C to B. First of all, I am going to obtain the shear force and bending moment diagram, bending moment equations for considering the A to C region. Okay. When you are going to obtain the shear force and bending moment diagram for A to C region, I am going to introduce imaginary cut, virtual cut in between A to C, the distance x from the AN, left hand side N. Okay. So then I am going to consider this separated beam part separately. So I am going to draw the free body diagram for the separated beam part. This is the free body diagram for the separated beam part. Okay. Then I am going to draw all the forces acting on it. First of all, the shear force acting on this cross section. The positive way we are marking is the downward direction when the shear force is acting in a left hand side face. The bending moment, this is the positive way we are marking the bending moment in left hand side plane. Then RAY is equal to 25 kilonewton. Okay. Then there's no any other load acting on it. So then we can easily calculate the shear force and bending moment, consider the equilibrium of this B part. Okay, before going to that one, so here we are introducing the imaginary cut somewhere in here. If you take the right hand side part, just for your information knowledge, I am explaining the shear force, positive shear force acting upward direction. That means the reaction of this acting on this direction. The positive bending moment acting in this way. Okay, this is how we are marking the positive shear force and positive bending moment. If we take another imaginary cut somewhere in here, the force is acting downward direction shear force and the bending moment acting other way around. So that if you take the middle part of the beam, due to act of shear force, it is tends to rotate clockwise direction. That is the way we are marking the positive shear force. And it is subjected to, due to the bending moment, it is subjected to a, in this kind of bending called sagging bending. Okay, that means the upper fibers are subject to compression while the lower fibers are subject to tension. Okay, this is the positive way of marking shear force and bending moment. Okay, then let's try to obtain the equation for. So I'm going to resolve all the forces in vertical direction. 25 minus shear force equal to 0. Shear force equal to 25 kilonewton. Then I'm going to take the moment around the A point. I'm going to take the moment around the A point. By taking the moment around the A point, bending moment minus shear force, this distance is equal to x into x is equal to 0. So bending moment is equal 25 into x. Okay, these are the two equations for shear force and bending moment. Consider the region A to C. So then we are going to consider the region C to B region separately. Then in this time I am going to introduce the imaginary cut in between C to B somewhere in here. Again the variable x distance from A. Okay, so let me draw the free body diagram for this separated beam part. So I am going to take this side, or you can take this side also. Anyhow, I am going to take this one. You can understand easily. So that I am going to take the left hand side part. Here the point load 100 kilonewton force is acting. In downward direction the shear force is acting. The bending moment is acting. In upward direction 25 kilonewton force is acting. Similarly in previous I am going to obtain the shear force diagram, shear force equation by resolving the forces in vertical direction. By resolving all the forces in vertical direction, 25 minus 100 minus shear force is equal to 0, so that the shear force is equal minus 75. Again I am going to take the moment around the A point. By taking the moment around the A point, we can write the bending moment equation. Due to this 100 Newton point load, minus 100 into 6 distance from this end is 6 meters, minus shear force into x plus bending moment is equal to 0. Okay, by taking the moment around the A point, we can write the equation minus because there is a in clockwise direction, minus 100 into 6 minus shear force into x plus bending moment is equal to 0, so that the bending moment is equal minus 75 into x plus 600 kilo Newton meter. Here is kilo Newton meter. Okay, these are the four equations for each A to C region. These are the two equations. C to B region, these are the two equations. Now we are able to draw the shear force diagram and the bending moment diagram. Let's see how to draw the shear force diagram and the bending moment diagram. Okay, now we are ready to draw the shear force diagram and the bending moment diagram for A to C region. The shear force is equal to 25 kilonewton. Then the C to B region, the shear force is equal minus 75 kilonewton. Okay, let's draw the let's draw the shear force diagram. at 25, then 75 minus 75 from here to here, this value is equal minus 75, here it is 25. This is the shear force diagram for this problem. Okay, let's obtain the bending moment diagram also. Bending moment diagram from A to C region, that is equal to 25 into x. It's like a y is equal mx type equation. The at bending moment at x is equal 6. What is the value? 25 into 6, that is equal to 150. Okay, 150 kilo Newton meter. Okay, somewhere in here x is equal to 0, that value is equal to 0. Okay, from when considered C to B region, at again x is equal 6, x is equal 6, that value is equal 150. Okay, at x is equal bending moment at x is equal 8, the bending moment is equal to 0. Bending moment is equal to 0. So that the equation is like this. Okay, either the maximum value we can mark, this value is equal 150 kilo Newton meter, alpha beta, tan alpha is equal 25, tan beta is equal 75. This is how we are drawing the shear force and bending moment diagram for this kind of problem. Okay, thank you.